Hi everyone and welcome to my YouTube channel. In this video we'll be discussing the SMC, which is the Senior Math Challenge for the UK in the 2024, which was held just 3 days ago. A brief look at the instructions. We have 90 minutes and we have 25 problems, and there are of course multiple choice questions. And there is like 1 mark deducted for each incorrect answer. Of course, if you leave it blank, then no deductions. And like 4 marks are awarded for the correct answer. Yeah, that's basically everything you need to know. And with that done, let's get started. Alright, so for the first question, we need to find 2/5 of the number 0.25, and this one has a period, so that means something like this: 0.25, 25, 25, and so on. So we need to find 2/5 of that. So first of all, let's divide this number by 5. Like the fifth of this number, clearly it's going to be this 0. And this thing divided by 5, it's just 5, so it's 0.5, 0.5, 0.5, and so on. And if we want to multiply this by 2, so it's just going to become, of course, if you multiply this by 2, then it becomes 10, so that means 0.10, 10, 10, and so on. So basically the answer is surely E. This is the answer. Alright, question 2. A TWIP is like a unit of length. It's basically that thing of meters, and a league is 4,800 meters. And the question is, we need to find how many tips are there in a league. Alright, so this is kind of a converter unit questions. So clearly what we need to do here is we need to catch the league. We know that the league is 4,800 meters, so we need to multiply 4,800. We need to multiply it, okay? This is this thing in meters, but we should know that to go from meters to TWIP, then of course you need to like multiply by the reciprocal of this. So we need to multiply by 1 over this. How many zeros do we have here? 1, 2, 3, 4, and then we have 18. So yeah, just that number. This is basically the answer. Now we need to calculate this. Of course, we should just here multiply by 10 to the 6, I think. Let's just double check. Here they will have 4 zeros, and here yes, 2 numbers. So if you multiply by 10 to the 6 here, both numerator and denominator, we're going to get 10 to the 6, and here we've got 10 to the 8, so it's 10 to the 8 times 48 divided by 18. Alright, if you look at the answers, all of them are 27, 27. So that means like it's better to make this 7 here and add a 0 here. This number is approximately 27. For example, you can just see that 500 over 20 is just 25. So yeah, kind of 27, this thing. So that means we just need to add 7 zeros. So 30, 30, and a 0. That's is our answer. Alright, we're done. Next, question 3. We have 2 dice. They're standard. So you just have like the standard dice, which is that means each 2 opposite sides, they add up to 7. For example, 1 and 6 are opposite, and 2 and 5, and 3 and 4. Okay, now they are telling us we have 2 of them, one on top of the other. Okay, that makes sense. We have only 9 of the faces can be seen, of course, because in total we have 12, 6 and 6, but we are missing the one in the bottom and the one up and the one that's above it, like the bottom of it. So we're missing 3 faces, so that means just we have 9 faces. Okay, now they're telling us that the touching faces have the same number. Alright, they're asking us the sum of the numbers on the, they're telling us actually the sum of the numbers on the visible faces is 33, and we need to find the number on the touching faces. Okay, so right now let's say the number on the touching face is x, then the one also here is x. Here the opposite one that's not visible is surely 6 minus x, because 7 minus x, because as we mentioned earlier, this is a property for any dice. You're going to always have opposite faces, they add up to 7. So that just means that the sum of these guys is just 7. Okay, right now they're telling us the sum of all the faces except x and 7 minus x. Like generally speaking, we know the sum of all the faces is of course the sum of the numbers from 1 to 6 times 2. And we can calculate this. So the sum from of numbers from 1 to 6 is just going to be 1 to 6, going to be, you can pair them, 1 with 6, 2 with 5, and 3 with 4. So it's going to be 21. 21 times 2, because we need to multiply that by 2. That's going to become 42. So this is the sum, the total sum. But we need to subtract the 33 to get the sum of these guys. So if we subtract 33 from this number, we're going to get 7 plus 2, which is just 9. So that means that the sum of these guys is 9. Of course, this plus this is 7. So that means this guy x here should be 2. So that just means that the answer is 2. And we're done. Next, the sizes of 3 angles in a triangle in degrees x, 7x, and x squared. And we just need to find the largest angle. Okay, this is very easy. We know that in any triangle, the sum of the 3 angles is just 180 degrees. So you can just create an equation here. So it's going to be x squared plus 7x plus x, which is just 8x, is equal to 180. You can, actually just do this. X times x plus 8 is equal to 180. And you can try to guess what is the number x. You can easily see that 10 is the answer, because 10 times 18 is just going to be 180. You just need to find 2 numbers that their product is 118, and they only differ by 8. So this is your best choice. Of course, that means that x is just 10. Okay, next. We have the number 4 to the 5 times 5 to the 4. This number, when we write it, how many digits are there? Okay, let's try to calculate this, because we can always pair these guys together. So let's just turn this into 2s and 5s. The 5 is already 5 to the 4, but the 4 to the 5, you can just write it as 2 squared to the 5. And of course, you can just use the properties of powers. So when you have 2 to the 2 all to the 5, that's just 2 to the 10. So you have 2 to the 10 times 5 to the 4. Okay. Now if you pair the 2s with the 5s, you're going to get 10s, which is really nice. So you're just going to have 2 to the 6 times 10, like this number, 10,000. And what is 2 to the 6? Of course, it's just 64. So the answer is just 64. And you have 4 zeros. So how many digits? 6, basically. That's the answer. Okay. Next. One face of a solid polyhedron is an octagon. An octagon is you just have a regular polygon, which has 8 vertices or 8 edges, and we need to find the smallest possible number of edges this solid could have. Okay, so right now we already have an octagon, something like this. Sorry, this. This is one edge. Now, if you try to think about, since this thing is just a solid polyhedron, then you need to have each one of these guys is going to be, you know, going up. So what is the, of course, we need to minimize the number of edges. We already have 8 here. So you know what's the easiest way to just minimize? It's just, instead of making all of these like different, why don't we make all of them points to the same point? So something like this. If you just make all of these guys go to a single point, now you can just think about this, like it's kind of a hat. How many edges we have? Of course, we have the original 8 edges, and we have the additional 8 edges that we just draw, and of course, it's going to be 16. For sure, this is the minimum number of edges. All right, let's move on. We need to take the number 3 to the 8 minus 1 and find the largest prime factor. Okay, so this question is just some factorization, which is really important. You really need to always learn how to factorize before you go to any regional math Olympiad, because there are always going to be some problems about it. Okay, this is pretty easy because you have a power of 2 here. You can always use the difference between two squares. So let's do it. First of all, it's going to be 3 to the 4 plus 1 times 3 to the 4 minus 1. Then this one we can repeat the same trick again. So we can erase it and make it 3 square plus 1 times 3 square minus 1. Of course, 3 square minus 1 is just 8. So it's 8. And 3 square, 9. This one is 10. We just need to calculate 3 to the 4. It's basically 81. 81 plus 1 is 82. So it's 82. 82 is just 2 times 41. So 2 times 41. So from here you can easily see that the largest prime is just 41. Okay, let's move on. In the following expressions, these expressions, we have 5 ones. X is a non-zero number. Okay, they're telling us when one of these expressions is removed, we're going to remove one of these. The mean of the remaining 4 is 11x. And what is the expression that's removed? All right. Right now, since we're like working with means and stuff, let's first of all find the total sum. We should always like go from mean to the total sum because you can always find it. So right now the total sum here, let's find it. So 4 plus, okay, we have a nice pairing. Okay, 4 and 16 is 20, and 8 with 12 is also 20, and this one is 20. So that means just 60. So the total sum is 60x. Okay, nice. Now we're going to delete one of these guys and find, let's say, the mean of these. So they are telling us that the mean of the 4 remaining numbers is 11x. So that means if you multiply 11 by 4, this is like the new sum after we delete this number. So now that means like this, if we add to it the deleted number, we're going to get 60x. So that of course means that if we just subtract this minus this, we're going to get our number, which is just 16. And yeah, that's it. Okay, now let's move on to question 9. So now we have a palindromic number. It's like a kind of a mirror number, a symmetric number. When you read it, you know, 3, 3, 2, 2, 1, 1. If you read it from left to right, it's the same as from right to left. So now they are telling us what's the hundredths digits of the largest 6-digit palindromic number. So right now the information we have a palindromic number that is 6 digits. So that simply means the number is something like this: A, B, C, C, B, A. They are telling us it's divisible by 18. So that means it's divisible by 3 and by by 9 and 2. So since it's divisible by 2, that means A should be even. And because A is also here, it cannot be 0. So A can be 2, can be 4, can be 6, can be 8. And we know that the number is divisible by 9. So that means the sum of the digits is divisible by 9. Of course, the sum of the digits is A plus B plus C plus A plus B plus C. So that means it's 2 times A plus B plus C. So that just means that A plus B plus C itself, it's a multiple of 9. So that means that a plus b plus c, it's a multiple of 9. What are the multiples of 9 possible? They can be 9, it can be let's see, 9, it can be 18, it can be 24. It cannot be anything like above that, because the maximum thing here is 9 plus 9 plus 9. It's going to be 24. Sorry, what I just say? 9 plus 9 plus 9, that's just 27, I mean. So we cannot, of course, jump to the next number because it will not satisfy. The maximum value here is just 27, so we cannot get the next number. And here 27. Okay, so that just means that these are the only possibilities. But now if we just look at the question again, they told us that they're asking to find the largest such a number. So if we want to find the largest such number, right now we have gathered some conditions. First of all, we know that a can be 2, 4, 6, 8, and we know that a plus b plus c can be one of these. Now, if you we're going to think of possibilities. If we take the sum is 27, then that means all of them are 9s, right? But this thing will not be even, so that means this one is not accepted. So we can have either 9 or 18. Since we're trying to maximize our number, so we should probably pick 18. So if you want to pick 18 and you want to maximize your number, you're going to pick the largest, you want to maximize a. Of course, to maximize a, you should just get 9, make it 9. If we make a 9, we get a contradiction again because a is even. So that means that the best value for a is just 8. Okay, now we got 8. Now that means b plus c is 10. Of course, we also want to now maximize b, so we cannot make b 10. So the only way we can make it is 9. And now c is just 1, so that means this is our number. And the question asking us, find the 100 digits, that means it's just 1. Here it is. Alright, so that's it. Next, the prime factorization of 2024 is 2 cubed times 11 times 23. Okay, this is like a good thing they are actually telling us. Usually it's you should already, when you go to a contest, know what's the prime factorization of the year. But right now, okay, thanks to them, they already told us that. No need to calculate anything. Now they're asking us how many 2-digit numbers are factor of 2024. So we need to find the factors here that are just 2 digits. Okay, let's try to think about this. So right now, if we want to have 23, then we can either have 23 itself, or of course these guys together, they cannot be together because they will clearly give us 3-digit number, not 2-digit. So we need to have this with some of these guys. Either if you don't pick any, so you just have 23, or if you pick just a single 2, that's also acceptable. Or if you have pick a single 4 times 23, it's less than 100, so that's also acceptable. But if you pick 8 times 23, for surely it will not work. So that means 2023 itself, it's going to give us 1, 2, 3. Yeah, 3 of them, either with 1, either with 2, either with 4. So 2023 itself gives us 3. Nice. Now 11, using the same technique, we can either by itself 1 or 2 or 3 or 4 or even 8, because 8 times 11 is 88. So right now that means 23 gives us 3. This guy 11 gives us 4. 2 cube itself doesn't give us anything. So that means just the final answer is 4 plus 3, which is 7. So the answer is just D. And now we can move on to the next question. Okay, question 11. Which of the following is a square number for any positive integer? And they're giving us some expressions: n plus 1, n times n plus 1, n times n plus 1 plus times n plus 2 plus 1, and D and E as well. Okay, how can we do this question? Well, guess what? They're telling us that like it's going to be always a perfect square for any number n. So of course the easiest way is just to try to plug some value of n, right? So for example, we can just plug 1 here. If you plug 1, n equals 1, and try to calculate, and you can rule out if you get anything that's not a square. So 1 plus 1 is 2. Okay, we rule out a. Here, 1 times 2 is 2. 2 plus 1 is 3. We rule out b. Here, 1 times 2 times 3 6 plus 1 is 7. We rule out that. Now 1 times 2 times 3 times 4, that is 24, plus 1 is 25. Okay, nice, 25. Now this thing here, we already calculated this is 24. This thing is 5 plus 1. So if you want to calculate this, then 120, 121. Yeah, this thing is 11 square. So now we have like either D is the answer or A is the answer. Just to get the answer, now we just plug 2. If you plug 2, you can just calculate this number, and you will see that actually it will not work. It will not be a perfect square, so that will just leave that D is the answer, and that's it. You can just solve it by making it, like putting examples, special cases. However, if you're looking for the actual proof, how can we show that this is always a perfect square? This one actually is very standard trick that always appear in regional math Olympiads. If you have a product of 4 consecutive numbers and then you add 1, you're going to get a perfect square. To do this, you can always do this expanding, but in kind of a nice way. You're going to pair these guys in a smart way. The smartest way to do it is to pick n times n plus 3 and n plus 1 times n plus 2. So if you multiply n by n plus 3, you're going to get n squared plus 3n. And if you multiply n plus 1 times n plus 2, then you're going to get also n squared plus 3n, but plus 2. And now here comes the nice trick. When you have two numbers that differ by 2, then you can always use this trick. If you make this guy here a, or let's say, if you make the number m squared plus 3n plus 1, if you define this as a, then your product is just a minus 1 times a plus 1. Of course, you have plus 1. Now this thing is just a square minus 1 plus 1, which is just a square. And hence, indeed, it's always a perfect square. So always keep that in mind. A product of 4 consecutive numbers, if you add 1 to it, you're going to get a perfect square. And you can always follow this technique to make sure that, yes, indeed, this is the thing. And of course, here we don't even need to do it. You can just solve it in no time by just trying 1 and 2. You're going to get it. Okay, let's move on. All right, for this question, we have P, Q, R, and S are two-digit primes. They're telling us that they use all non-zero digits except 5. We need to calculate P plus Q plus R plus S. Okay, so we have 4 numbers. Each single number is 2 digits. So in total, we have 8 digits. And we don't have 5, and we don't have, they're non-zero, so we don't have 0, of course. So that means, let's focus on that. Right now, we have a 2-digit number, and it's prime. So we know it's, of course, any prime is odd. So that means we already have all the odd numbers. So we can write them as the units. 1, 3. 5 is not there. So we have 7. And we have 9. And of course, now that means the 10th digits are 2, 4, 6, and 8. And these are going to be distributed there. But guess what? Does it really matter? We need to think about it, how they are distributed. Let's see what's the question. The question is find P plus Q plus R plus S. So if we want to simplify these numbers, the sum of them. So it really actually doesn't matter, because when you add numbers, then you add just the units, and then you add the tens and multiply that by 10. So basically that means that just the answer is 1 plus 3 plus 7 plus 9 plus the sum of these, 2 plus 4 plus 6 plus 8 times 10. So let's just find what is that. So 1 plus 9 is 10, 3 plus 7 is 10, so that's 20. Plus, we need to add these, 2 plus 8 is 10, 4 plus 6 is 10, so 20 times 2, so 200. So the answer is just 220. And that's it. You don't need to bother yourself and think about the possibilities. Okay, let's move on. Now we have here a diagram. It's kind of a Pascal triangle here, something similar. So the idea is each number here is the sum of the two below it. Like Z is the sum of these two, this is the sum of these two, and so on. And we need just to find what is Z, given that we have some of the numbers there. So yeah, we can just here create some variables and solve this. So if this was X and this is Y, then this is X plus 1. This will be X plus Y. This is going to be Y plus 10. And the number is going to be 2X plus Y plus 1. Let's zoom here. And this number is going to be 2Y plus X plus 10. And of course we have that 2024 is the sum of the numbers below it. So that gives us an equation that 2024 is the sum of these guys. And these guys are just, if you add them, is 3x plus 3y plus 11. So let's subtract 11 from this. I'm going to get 24 minus 11, 2013. We need to divide this by 3. So if you just divide this number by 3, you're just going to get 671, which is x plus y. And guess what? Z is just x plus y. So this is the answer basically. Where is 671? Yeah, here it is. It's C. Okay, we're done. Next, P, Q, R, S, and T are the digits 1, 2, 3, 4, and 5 in some order. Alright, P, R, T, and Q, R, S are both 3-digit primes. Which digit is R? Alright, let's analyze that. These two numbers are primes. So for sure T and S, they cannot be 2 or 4. They cannot be 5. So there are, one of them is 1 and the other is 3. So these numbers, one of them is 1, the other is 3. It doesn't really matter which one is which, because it doesn't really matter. Like we can just swap them. We just asked to find R, which is this. Okay, so we figure out the unit digits 1 and 3. We can now cross these. Now we just have 2, 4, and 5. Okay, we need to figure these out now. Okay, now let's figure out the possibilities. So right now 4 and 5, they cannot be together here, 4 and 5, because 4 and 5 and 3, if you add them, you're going to get 12, which is a multiple of 3. So it's not going to be a prime anymore. So 4 and 5 cannot be both here. What does that mean? Think about it. Can we have, that simply means, since you cannot have 4 and 5 here, that's, if this was 4 here, then 5 is going to be there, right? Surely. And if 4 was here, then 5 is going to be here. Or 4 is here, and now we don't have any condition, like 5 can be here or here. Okay, this is kind of not enough. We have too many possibilities. Let's try to think. Can we rule out any? Okay, so right now we just know that 4 and 5 cannot both be here. What can we also think? 2 and 4, they add up to 6. So also the same idea. 2 and 4 cannot be here. So that means that if you have 4, then you're going to either have 2 or 5 here. So both of them will not work. So that means that 4 cannot even be here. So that means 4 must be the P. Very good. So now we rule out 4. Now we just have the 2 and 5. So now we have two possibilities. Either we're going to have 2 here and 5, or we're going to have 5 here, 2 and 5, and this. But of course now this thing is multiple of 11, so this thing is ruled out. So this is the answer, the only possibility. So R basically is 2, and we're done. Next, we have in this diagram 2 squares, as you can see, this one and this one, and they're telling us that the length of NL is just 10, and the shaded region is just 62. We need to find the length of KN, which is the length of the side of the smaller square. Okay, so to do this, of course, we need to assign some variables. Let's assign to this one, like to the small one, x, and to the big one, y. Right now, let's collect everything we know. So what we know is, since NL, like this thing is also x, so from Pythagoras we know that x squared plus y squared is equal to 100. We also know the difference between the two areas, which is y squared minus x squared is equal to 62. And our goal is to find x. But actually, if you just look at these two equations, they're really like nice and simple. You can just find x immediately if you just subtracted the two equations. So if you subtract this minus this, you're going just to get 2x squared is equal to 100 minus 62. 100 minus 62, that is 38. So let's divide that by 2. It's going to be 19. So x squared is 90. So that means just x is root of that. So C is the answer. We're done. Next, we have a set of cupboards, as you can see in this diagram. And we want to color them. Color actually three of these doors with red. And we have two conditions. The first condition is at least we need each row to has one colored door. This is like condition number one. We cannot, for example, have like they are colored like this, this, and this, and this. No, we need to have at least one here, and then the third one, it can be wherever. Next, the other condition is we need to have a minimum two corners colored. So this one and this one, for example, or this one and this one, whatever. These are only the only two conditions, and now we just need to count how many ways to do that. Okay, for sure we should go for the corner condition first, because it's really easier to work with. It gives us more instruction. So let's discuss some cases here. So either we're going to have this one is colored and this one is colored, these two corners, you know, but also like same thing if you have this and this. Let's right now focus here. If you have this one and this one, how many ways to do to choose the third? Right now both of the conditions are already there, because we have in this row and in this row we have a colored one. So now actually we don't have really anything else, so we can just have 6. Like we can either choose this or this or this or this or this. So we have 6 actually right now. So 6. Same thing if you have this, also you can like have 6. And you should always remember that you should always delete if you have repetition. So maybe, you know, we counted this twice, but actually we did not, because we cannot have such a possibility. We're just coloring 3. So actually, no, we don't. And now we already have 6 plus 6. Very good. Next, the other possibility is we have something like this and this. Now, if you have this and this, then actually you did not satisfy the first condition. So that means you must be, you must choose somewhere here. But however, remember that we already counted this before, and we actually counted this. So that means we only have either here or here. So it's actually just 2. Same thing here. If you have this one and this one, you can either go here or here. So you actually only have 2. And you can check that there is no intersection, of course, between these two cases. Okay, right now the only one that we're missing is this and this. Now we already satisfied the first condition. So now what we can do is do anything, literally. So we can choose here, 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 here. But we cannot choose here because we already counted that, nor here, we already counted that. So that means we just have 4 possibilities here. And similarly, we have this one and this one. We also have like 4 here. So that gives us, basically, yes, now we're done we've exhausted all possibilities, all cases. So this is just, the answer is 4 plus 6 is 10, 20, 24. Yeah, so the answer should be 24. Yeah, so the answer for question 16 is just B. Alright, let's move on. A bag contains 4 balls, each of which is colored either red or white. Okay, so you have 4 balls, red or white. they're telling us that we're going to assume that we draw one ball, we got it red. We also then we did not, of course, replace it. We also took another one, we also got it red. If the probability that we have this event happening, like the first chosen one is red, and the second one is also red, this probability is half. What's the probability that both balls are white? Okay, this is actually an easy question, an easy probability question. We just need to find what's the probability of the first one. So let's say we have R, like balls, the number of red balls is R, and the number of white balls is W. Of course, R plus W is just 4. First of all, what's the probability that the first ball is red? It's just R over 4, clearly. Now, after we did that, now how many red balls are there? R minus 1. So also the probability that we get another one, it's R minus 1 over 3. So this number here is just equal to half. And now we can just figure out what is R. So that just means, okay, we can cancel the 4 with 2, it's going to be 2. So 6 R times R minus 1 is 6. So what is R? Clearly R is 3. So if R is 3, that means W is 1. So we have a single white ball. Now think about what's the probability that both balls are white. So if we already picked the first ball is white, then we don't have even a second ball. So it's 0 actually. Because as we said, we just have a single one white ball. We cannot find it twice. So we just have 0. Okay, that's it. Let's move on. Question 18. We have in this diagram two concentric circles. They have the same center. And they're telling us that these segments here are, of course, dividing the like this into 14 pieces, I think. Yeah, let's see. 1, 2, 3, 4, 5. Yeah, and we also have 5 here. So you have basically 10, and you have 4 here. Yeah, they're telling us that the areas are all equal. So the area here is equal to the area here. Very nice. And they're giving us that the radius here is just 1 of this smaller circle. They want us to find x, which is the outer radial line. Okay. Right now, to do that, since we know this one is 1 and we're asked about areas, so let's find just what is the area of this. So the area of the circle is pi times r squared. So it's just pi. So the area here is just pi. Okay. So that means that each one of them is just pi over 4. Pi over 4, the area of each single piece. In fact, right now, since we have pi over 4 is each one of them, then what's the total of all of them? It's just going to be this times 14. So this is just going to be 7 over 2 times pi. So that means we know what is the big R, the R of the big circle. R squared is 7 over 2. So what's R? R is root 7 over root 2. Or, if you want to rationalize the denominator, then you can just multiply by root 2, make it 2, and make this 14. So this is big R. But the question is not about big R. The question is about this thing here, or this thing. So of course this thing is really easy. Just the big R minus the small r. So this thing we just need to subtract 1 from it and we get the answer. So the answer is just C. This thing minus 1. And we're done. Alright, let's move on. Okay, 5 friends are dealt 2 cards, each from a set of 12 cards. Okay, we have cards numbered from 1 to 12. And the friends declare the sum of the values of their 2 cards. Yeah, so each friend has 2 cards. And we have 5 friends, so in total we have 10 cards. And they're giving us the sum of the values for, each guy adds his 2 numbers. Okay, so let's just try to analyze the situation. So we have each person has like two numbers, A and B, for example, the next one C and D, and he calculated A plus B. So we have what is A plus B, we have what is C plus D, and so on. So we just have actually one pair that's missing. We don't have its sum. No problem. Right now, let's think about Paulo first. So Paulo has like scored 4. So A plus B for Paulo is 4. How can we get 4? Either 1 plus 3, 3 plus 1, or 2 plus 2. Sure 2 plus 2 is refused because it cannot be repeated. So we already figured out Paulo. Like let's say Paulo like P. His set is 1 and 3. Okay, we figured out Paulo. Next we have like Quinn is 11. So if you think now about 11, the problem with it is it has too many cases, too many possibilities. Of course, it's the same thing for 16, 19, and even 20. 20 can be like many possibilities. For example, 12 plus 8, 12 plus 8. It can also be 9 plus 11, and many other possibilities. Or I think actually maybe just these two. So right now, how can we like do this question? We have too many possibilities. We don't want to waste too much time on this question. So what should we do? Well, remember, we have already two missing cards. These two cards, they did not tell us their sum, but can't we figure it out by ourselves? Well, sure we can. Remember, we know the total sum. The total sum is the numbers from 1 to 12. What is the total, like the sum from 1 to 12? From 1 to 12, it's just, the first number plus the last number 13 times 12 divided by 2. So that's just 6. So it's basically 60 plus 80. So it's just 78. So this is the total sum. Now they told us there's the sum of each two. So now we're just going to add these numbers, 4 and 11 and 16 and 19 and 20, and then subtract them from this number, 78, and we will immediately figure out the sum of the missing numbers. So let's just do that. So 4 plus, if we want to add these, 4 plus 16 is 20, and we already have a 20, nice. And we have 11 plus 19 is 30, so 20 is 40, and 30 is 70. Yes, so it's 70. You see, so if you just, that means that the missing numbers, let's call them x and y, x plus y is equal to 8. Now think, what are the possibilities for like two numbers that add up to 8? It's 1 and 7, or 2 and 6, or 3 and 5, or 4 and 4. Then they will just repeat again. However, we already have 1 here, so this is refused. 3 is already there. This one is refused. 4 and 4 is surely refused. So that means that indeed they are 2 and 6. Very good. So that means we figured out what are the missing numbers. So they are 2 and 6. 2 and 6. So the missing number, let's call it whatever, like let's say 5 or something. 2 and 6. Okay, now we can go to Quinn and figure out the 11, because now we've reduced the number of numbers. So maybe we can immediately find out what is Quinn's number. So remember, we have 11. What are the possibilities to get 11? 1 plus 10. 1 plus 10. 1, we don't have 1. So is it 2? We also don't have 2. 3, we don't have 3. 4, well, to have like 4, we need to also have 7. So 4 and 7 are a possibility. Do we have other possibilities? 5 with 6. Okay, 6, we already have it there. Now, we're done actually. So that means that now Quinn numbers are 4 and 7. So you figure out like Quinn's number. Let's move on to Romy. So Romy has 16. Again, what are the possibilities for 16? We already now like got rid of 1, 2, 3, 4. So we might have 5. 5 with 11, right? 5 with 11 is a possibility. 6, we don't have 6. We don't have 7. Do we have 8? 8 with 8. Okay, not possible. We're already done. So that means we already found Romy. Guess what? The question is, which of the following statement is true? Paolo has 2. No, he does not have 2. Quinn has 3. Well, queen does not have 3. Romy has 5. Romy has 5. So we don't need to continue. Already got it. Like this statement for sure is true. Okay, let's move on. Let x, y be positive integers. We have 1 over x plus 1 over y is 1 over 20. We need to maximize y. Okay, this is very standard question. These types of questions you immediately multiply by like 20xy to make it just a kind of a Diophantine equation, an equation with integer solutions. So your equation is just xy minus 20x minus 20y is 0. And this thing has really very standard, famous way to factorize this. It's called SFFT or whatever. We can just, the key trick is to imagine we already factorize this. We're going to need x and y to get x and y here. How do we get like minus 20x? We need to have here minus 20. How do we get minus 20y? We need to have minus 20 here. So now, okay, we factorized it. However, we have an additional 400. So this thing is actually equal to 400. And now you can, just have possibilities. Two numbers there, product is 400. But because the question is asking us find the maximum value for y, so we want to maximize this. Of course, the best way to maximize this is to make it 400 and to make this guy here just 1. So if you just do this, this thing is equal to 400, then y is just 400 plus 20. So it's 420. Alright, keep this idea in your mind. This factorization is very famous. Okay, next, question 21. So the cross number, we have a cross number here. We have digits from 1 to 9. And each number is just used exactly once. Of course, we have one missing number here. They are giving us some info, of course. They are telling us that this number here that you get, it's a multiple of 9. This number here, you get 3-digit number is square. This number here is a multiple of 11. This number here is a multiple of both 13 and 19. All right. So which info should we use first? Well, clearly this info. Because if a number is a multiple of 13 and 19, and because 13 and 19 are co-prime, they don't share any, common factor. So that means this number here should be a multiple of 13 and 19. So it should be a multiple of 13 times 19. Both 13, like 13 times 19. What is 13 times 19? It's 247. So that means this number should be a multiple of 247. So what are the possibilities? It's either the same number or this number times 2, which is 494. Or this number times 3, which is 741. Okay, if we multiply by 4, we're going to get 988. But guess what? You can immediately rule out this. You can rule out this because it's giving us repeated numbers. So that means the only possibilities are either 247 or 741. One of them. Okay, very good. We already figured out two possibilities for this column. Now what should we use? Now actually, if you think about it, if you have 2, 4, 7, remember here they're telling us that this thing is square. They're giving us that this guy here is a square. The question is, do we have a square that ends up with 7, has unit digit 7? Well, you can try yourself and try all the possibilities for a unit number. If when you square it, you're going to get, for example, if you have a number that ends with 0, if you square it, you're still going to get 0. If you have 1, you square it, you're still going to get 1. If you have 2, you square it, you're going to get 4. If you try like 3, it's going to give you 9. 4 is going to give you 16, so 6. And 5 is going to give you 5, because 25. 6 is going to give you 6. 7 is going to give you, actually, 7 square. So it will not give you also 1. Yeah, basically 7 square is just 49, so it's just 9. And 8 the same, and 9 the same. None of them will give you 7. So that means that, guess what? We already ruled out this. So that means that right now we have something like this. 7, 4, and 1. Alright, that's nice. We've done a good job of getting rid of 3 numbers. So right now, let's continue. Let's think about it. We also have the square condition. If we look at the square condition, we have like the unit digit of a square number is 1. How can we have that? The only way, the original number, like the root of it, right now for sure the number is something like this, a1, right? a1 squared. It's going to give us 1 and 2 numbers here. Actually, not exactly. It's not necessarily 1 here. It might be 9 as well. Because 9 squared is also going to give you 1. And in fact, these are the only possibilities. So that means that this number can be anything like this. 8-1 or a1 or a9. And you square them. Okay, so now of course you can try these numbers. Let's try like to put a with something. So if a was 11 or was 1, I mean, so 11 squared is 121. Let's try all of them. 121. This thing can also be 2, so 21 square. 21 square is basically 441. Now we try 31 square. We get 961. Okay, clearly 41 we should not try it because it's going to be a 4-digit number. So right now this actually, this one is refused, this one is refused, this one might be. Okay, now let's try the 9. So now for the 9 we can have of course 19 square, which is 361. We can also have 29 squared. It's going to be 841. Yeah, that's it. We should not try 39. It's going to be too large. So let's see, are these acceptable? Okay, like we don't have repeated number, but remember we already consumed 7, 4 and 1. So of course 1 is already there, so we should just look at the 4. This one is refused. So we have now 2 possibilities, I guess. 961 or 361. Yeah, these are our possibilities. Okay, in both cases we already have here 6. So here we're either going to have 3 or a 9. 3 or a 9. So here 3 or a 9. They both work. Okay. Next, what do we also have? We have that this guy here is a multiple of 9. And this guy here is a multiple of 11. Okay. Let's think about it. What can we do now? Which one should we choose? Now, if you think about this number here, this number, remember, it's a multiple of 9. So that means the sum of the digits is a multiple of 9. So we have this digit plus digit plus 7 is a multiple of 9. What are possible multiples of 9? 9, 18, 27. Of course, it cannot be 27 because we'll have like all of these numbers to be 9s. They are not. Can it be 9? Well, we already have this number is 7. So like the only way for it to be is we're going to have 1, 1. So also refused. So that means it must be 18. But this number is 7. So that means the sum of this plus this is 11. Okay, very nice. So that means if you have a number a here and b here, then a plus b is just 11. Have a plus b is 11. So now actually if we try our luck here, and we have 2 possibilities here, 3 and 9. So if we just imagine that we have a 3 here, it might work or not. We're going to try 9 later if it did not work. If we have 3 here, then now if you think about a plus b is 11, how many possibilities there? Like either the first number is 1 and 10. Okay, we cannot have that. 2 and 9. 2 and 9 is acceptable. We cannot have 3. We choose 3. We cannot have 4. We have 4 here. We can we have 5? 5 plus 6. We cannot have, because 6 is not there. And you can see that means we cannot. Like, the only possibility is to have 2 and 9. So we can have 2 and 9 or 9 and 2. If we try 2 and 9, now the only condition, all the conditions are met except the 11 condition, multiple of 11. So if you want this to be a multiple of 11, then you know the condition 2 plus 3, 5. If you have actually here 5, then 5 minus 5 is 0, then it works. So in fact, this actually square indeed works. So that means, like here in this case, the missing number is 8. 8. Do we need to check the others? Well, no, because this is not a proof. Like, we don't need to exhaust all cases. If we just find a working solution, then guess what? We're lucky, and that's it. It's enough, because this exam is just a multiple choice, right? You don't have to prove all the cases, or discuss all the cases. So if you got just even if you guess the cases, then the working solution, then it's okay. You just find the number. Okay, then let's move on to the next question. In this question, we have a diagram. We have a triangle, and we have some points there, and they give us just the areas of these triangles, 4, 8, 12, and 8. They want us to find the area of IKH. IKH, that is this triangle. This triangle. Okay, but before, if we try to analyze this, of course here, whenever you have an areas and triangles, and this is a very, very famous and standard technique we're going to use with areas, and you will see it in all regional math Olympiads. That is the areas ratio. Whenever you have a triangle, A, B, C, D, then you should know that the area of ABD, the ratio of this over the area of ADC, is just equal to the ratio of the sides, the bases BD and DC. The reason is simple. If you drop an altitude here, it's going to be the same altitude for both of them. So it's going to cancel, and you're just going to get that BD over DC. Same thing if you set this over the whole triangle, it's also going to be BD over BC. So yeah, you should always keep this in your mind. So right now, if you just try to analyze this one here, so this one is actually, if you look at this, this one here, the area is 12, and this one is 12. So that means that K is the midpoint. So actually, that just means that K is the midpoint. So this thing is equal to this. Very nice. We've collected, some information about K. Okay, now let's focus on our triangle. How can we find this triangle? Well, to find this triangle, we're going to exactly use the same thing, same trick. So since we have this base here, then we can just move on to the bigger one. We can get rid of point I since it's bad. So we can just say that KIH over KFH is just equal to IH over HF, all of it. But can we figure out that from the info they gave us? Let's see. We want IH, so if we look at this triangle here, we know that this one here is 8, and we know that the total is 32. So that means this, if you divide it by 32, 8 over 32, it's going to be 1 over 4. So this is kind of 1, and this is 3. Yeah, so this is actually 1/4. So now if we return to our question, we needed to find this. We just can say that KIH is equal to 1/4 of KHF. Okay, now KFH is much simpler to work with. Okay, in fact, right now, KFH is just, since K is the midpoint, it's just half of, so it's now 1 over 8, the big triangle, which is FHG, of all of that. And that, of course, FHG is just 32, so the answer is just 1 over 8 times 32, that is 4. So the answer is just 4, and that's the answer for question 22. Okay, Let's move on. So in this question, they're telling us that we have a hat tile, which is this diagram here, you can see it, and it's divided into 8 congruent kites. You know what is a kite? A kite is just some shape like this, where you have this is equal to this and this is equal to this. So kind of you have two congruent triangles above and below. Anyway, we have 8 kites, as you can see in the diagram, and they're telling us the area of the total shape, like the whole shape, is 8 times root 3. So of course that means that the area of each kite is just root 3. Okay, what's the perimeter of the hat tile? Now, this kite, we only know that the area of it is root 3. So how can we deduce the perimeter of this? Like, we don't know the length exactly. Well, actually, if you just look at your diagram carefully, you will see that you know many info about the kite. For example, if you just look here, you already see that this angle here, of course they are congruent, so x. So that means that x is 90. So that means that our kite has a 90-degree angle. Second thing, if you look carefully here, also this is equal to this, so that means it's 120. So that means now we know everything about our kite. So our kite is something like this. We know that this is 90. We know that this is 90. We know that this is 120. So if you cut this in half, it's going to be 60. This is going to be 30. So that means that if this was x, then this is root 3x. And of course, if you want to find the area of that shape, then it's just half of x times root 3x plus times 2, so we don't have a half, so it's root 3x squared is equal to root 3. So that automatically means that x is 1. So we have one of them is 1 and the other one is root 3. So the smaller side is 1 and the bigger side is root 3. So now that means that we know everything about our kite. Now it's time to find the perimeter. Okay, let's see how many small sides do we have. Okay, 1, 2, 3, 4, 5, 6, 7, 8. Okay, so 8. So that means it gives us 8. Okay, now how many big sides? 1, 2, 3, 4, 5, 6. So that's 6. So 6 root 3. Okay, looking at the answers, we see that yeah, it's 8. It's E. So the answer for question 23 is just E. Okay, now we can move on to 24. Okay, so this is actually a functional equation here. We have f of x plus f of 1 over 1 minus x is equal to 24x. And they're telling us this is always correct. Of course, we cannot have x is 0 or x is 1 here. They're telling us what's the value of f of 3. How can we find f of 3? They did not really give us the function, but they gave us this nice equation. So what we can do is, of course, the easiest thing is to just go and plug x equals 3. So if we plug that, you're going to get some nice thing. You're going to get f of 3 plus f of negative half. It's equal to 3 times 24, which is 60 plus 12, yes, so 72. Okay, we did not find f of 3. We just linked f of 3 with f of negative half. What should we do now? Well, the idea is also simple. Why don't you go plug x equals negative half? Maybe you're going to get something. So if you plug x equals negative half, then you're going to get f of negative half plus f of... Okay, now we need to calculate this. Negative half times negative, it's half. Half plus 1 is 3 over 2. So if you take the reciprocal of 3 over 2, 2 over 3. Of course, now we can plug the x equals negative half, so negative half is going to give us negative 12. Okay, unfortunately we also got 2/3, but what can we do? We should just repeat this again. So let's now plug x equals 2/3. Hopefully, let's hope that we get something nice. So 2/3, 1 minus 2/3 is third. All right, now we got something nice. We got 3. And of course, we just plug 2/3. So third of 24 is 8. 2 times that is 16. Finally, now we have 3 equations, 3 linear equations, and 3 variables. We can for sure calculate f of 3. The easiest way is just to add all the numbers up. If you add them all up, you're going to get, yes, just 4 plus 72, which is 76. So this, if you divide it by 2, you're going to get the total sum of f of 3 plus f of negative half plus f of 2/3. And this number is just, I think, okay, 80, 40 minus 2. So it's just 38. So 38 is equal to f of 3 plus f of negative half plus f of 2/3. And now if you go to the second equation, you know that what's this sum? This sum is just negative 12. So that means that f of 3 minus 12 is equal to 38. So now if you just move it to the other side, you're going to get the answer is 50. Yeah, that's it. This is the answer for question 24. Finally, the last question is question 25. All right, let's move on here. Let's look at the diagram. We have 3 semicircles. Each of them has area 24. So that means all of them are, of course, congruent. Like the radius for each one of them is equal to the other. Okay, they are telling us that we have like x is the center of the first one, y is the center for the second one, and the third one is just the same as this circle, but we just rotated 30 degrees, as you can see here. Okay, and now we just need to find the area of the shaded region. All right, these types of questions are a little naughty because you need to try just to find these areas and maybe like put like some area over another area, or you know, move some stuff. Anyway, for sure we need to zoom here and look at this lovely diagram. What can we figure out here? First of all, remember that we know the area of each semicircle. They told us actually here it's 24. So the total area of the whole semicircle is 24. Not forget that, 24. Okay, now what we know is that all of these are congruent, and x is the center, y is the center. So that means that this thing, for example, xy is also the radius, the same radius. Okay. Okay, so now let's focus here on the first shaded region. Can we find the area of it? Well, guess what? We have this semicircle, and this area is just, we took a 30 degree segment. So of course you can find it, because you can also like find like another 30 degree and another 30 and another 30. We can cut it to how many 30s? Like 180 has how many 30s? 6, of course. So that means it's just the area of 24 over 6, which is just 4. So that means that we already calculated this area here is 4. Alright, so let's call, you know, whatever, maybe x. The first area is 4. Nice. What about this area here? How can we find it? Well, this one is really naughty because it's going to have like 2 arcs here, an arc here and an arc here. It's not like this one. It has just like some segments here and then it has an arc. So here we need to do some tricks. What is the trick exactly? Well, let's see. If you look at this shape here, focus on this shape. Now I want you to focus on this shape. Aren't they identical? Right? They're just the same. And remember that here, like all the circles are like they have the same radius. So of course they are equal. They're the same, because like everything is equal. Like if you just take this triangle, then it's equilateral, because this is equal to this, radius, radius, radius. And same thing here. If you do this, this is equal to this, equal to this. So that means, okay, this shape here is the same as this shape here. But guess what? That means like automatically, if you just remove the white space, then these two are equal. And automatically this gives us a free 4. So this thing is just 4. Alright, now our final thing to find is just this thing. Let's hope that it's also 4. But still, like here we have also a problem that we have many arcs. An arc here and an arc here. And then like just a segment. So let's try to use a similar strategy that we used there. What can we do here? Well, if we do something like this. Yeah, okay, so if I just join this and join this, and now let's try to look at our diagram. Of course, if I draw this as well. Of course, we have this thing. Remember, it's a equilateral triangle, so this thing is also 30. In fact, this is 90. This is, of course, equal to this. Yeah, so what we can do here is we can move from this to this. These are equal. But, of course, that also means that this thing here is equal to this. So what this means is, like this thing is equal to this, and this thing is equal to this. So that means that if you just look at this thing here, this part here, it's going to be the same as the shape you want, but then you need to subtract this piece. Okay, again, I'm going to repeat that. Our shape here is this thing, the black. This black, this thing is the same as thing, we can map it here. But this thing here, if we add this to it, it's going to be the same as this. So right now, if I add this piece, I'm going to get this. So to find the black region, I just need to find this minus this piece. Okay, so if we keep that in mind, now we can get rid of this. So I just need to find this area and subtract this thing here from it. Okay, very nice. But now, if you look closely here, this thing here is equal to this. And of course, this thing here is equal to this. But what about this thing here? Well, here, this thing here, this arc here, is just equal to this arc. So that means, in fact, it's not just equal, like it's equal to this arc, and this, like times 2, it's going to give you this. You can easily see, because you know this is 30 angle, here this is 60. So like this arc is just 60, while this arc is 30. So of course it's, double it. So that just means that what we have exactly, we wanted to calculate all of this minus this part. So that means we just need to calculate this plus this, because as we said, this thing here is 2 times this. Very nice. So that means we just need to calculate this. But guess what? This thing is just equal to this black region here, because these two are equal. This here is equal to this, because each one of them is 30 degree. So guess what? It's also a 4 there. So of course the answer is just 12. Again, just a quick explanation. Like the first part should be clear. This one here, this one is also should be clear, but this one here is the naughty thing. The main idea we did there is we said that if I want to find this, I will just add and subtract this part here. So if I add it, then I will this thing is congruent to this. So that means I just need to find this whole region here minus this region. But guess what? This region here is double this. So you know, if you have here 2x and this thing is x, so 2x minus x is just x. So that means that I just need to find this area here. But this area clearly is the same as this area, because if you just focus here, this thing is just a bisector. So for sure they're equal. So that means I just have it the same as this, which is already 4. So this just gives us the answer that is just 12. And yes, that's it. We're done. Alright, so as a summary, we saw that this paper was not that hard. Like the questions are kind of, many of them are standard ideas. You know, you just need to be always alert and make sure you don't do a calculation mistake or you don't miss some cases. Like on general, this is like the rule of thumb in regional math Olympiads. You should always double check your answer and always be careful because especially that here you get a punishment when you like do a wrong answer. They deduct a point. So you should always be careful in these contests. Alright, like guys, let me know how you did in this paper, and like good luck to all of you. I hope you qualify to the BM01, and of course if you did not do well, then you still have like next year. You should study well and prepare well, and of course the best strategy is to try to solve the previous papers, all of the previous papers, and you can just learn the pattern, because many of the ideas are just repeating again and again. The mod ideas, especially the modular arithmetic, you should master it, and like these kinds of digits, recurring digits, and of course the area questions, the area ratios, all of these are really important. Yeah, so that's it guys. Don't forget to like, share and subscribe to the channel, and you can also join the Discord channel that we have on the description, and see you guys in the next video.